Welcome to Virtual Labs at National Institute of Technology, Karnataka. In this tutorial, I'll be showing you the experimental procedure for flow-through fittings. This is the experimental window. Aim of this experiment is to find the equivalent length of fittings like globe valve, gate valve, regular 45-degree bend, regular 90-degree bend, and return bend 180 degrees. Let's see how to do the experiment with this simulation tool. This is the line diagram of the experimental setup. This is a water reservoir, water or any fluid reservoir. Fluid is being pumped through this pipe, and required flow rate of the fluid can be set using this valve by opening, and this flow rate can be read from this rotameter. This is the globe valve. These are the pressure tappings connected across this globe valve. This is a manometer, CCl4 manometer. And let's do the experiment. Select a nominal pipe diameter, 1 inch. That is the pipe diameter. And select a fitting. Let's select globe valve. Select a fluid, water or anything. This is the benefit of this virtual labs. You can have number of choices in selecting a fluid, which is not feasible in real world experiment. And set a flow rate by opening this valve. Let's enter some flow rate 15 and manometer, CCl4 manometer. Click the button, calculate dP. This is the pressure drop, 17.1 centimeters of manometric fluid of means CCl4. This is 17.1 is the difference between the heights of the manometric fluid in these two limbs. And to set another flow rate, open the valve more, increase the flow rate. For that, reset and enter another value, 20 LPM. Calculate dP. This gives 28.26 centimeters pressure drop. And do the experiment for 4 to 5 readings. Some 25 LPM and 30 LPM. Okay. $35. Yeah, this is showing up some error. Manometric fluid is overflowing. At higher flow rates, this CCl4 liquid, it overflows and comes out of the limbs, manometer limbs. So this is the time for us to change it to Hg manometer. So change it to Hg manometer. And then same procedure. Click the button, calculate dP, and to enter next flow rate, reset, enter another flow rate, and same procedure. Hg manometer gives very less heights, 4.5 less difference in the heights of this manometer limbs, fluid limbs, even at higher flow rates. That is why we go for Hg manometer at higher flow rates. And reset and do the experiment for 2 more readings, 45 LPM, reset, and 50 LPM. To see all the readings results, press the button display results. These are the flow rates with which you have done experiment, and these are their corresponding pressure drops. And with this result, students are supposed to calculate equivalent length of the fitting. I'll show the sample calculations. This is the data. Diameter of the pipe connected to globe valve is 1 inch, that is 2.66 centimeters. That is nothing but 0.0266 meters. Density of water 1000 kg per meter cube. Viscosity of water 1 cp. Density of CCl4 1600 kg per meter cube. Density of Hg 13,600 kg per meter cube. These are the readings, our result. Let us see sample calculations for flow rate 20 LPM. The corresponding pressure drop is 28.26 centimeters of CCl4. At this flow rate, this is the pressure drop 28.26 centimeters of CCl4. Volumetric flow rate in meter cube per second. Let us follow SI units. And this is the pressure drop in meters of water column. And this is the cross-sectional area of the pipe, pi by 4 d square. D is 0.0266 meters. And average velocity of the fluid through the pipe, that is flow rate divided by cross-sectional area. This flow rate divided by cross-sectional area. Reynolds number dV rho by mu. D, V is velocity, density and viscosity of water. Density and viscosity of water. Then with this Reynolds number, calculate friction factor. This is the friction factor. And with these things, calculate equivalent length of the globe valve. LE by D is 2G HF by 4F V square. G is gravitational constant 9.81 and HF is the pressure drop in meters of water column, this value. And F is the friction factor, this value. V is the velocity, this value. With this, LE by D is giving 328.568, means equivalent length of a globe valve is 328.568 times of diameter of the pipe. Like this, all the calculations can be done for all flow rates. These are the two sets of flow rates. One is with the CCl4 manometer and one is, this set is with the Hg manometer. This is the flow rate, pressure drop in meters of water column, velocity, Reynolds number, friction factor and LE by D. After calculating all these values, equivalent length of the fitting, one can cross check their values with simulator calculated values. For this, go to self-evaluation. This is the self-evaluation window. And select a set of readings, CCl4 manometer, enter a flow rate 15. At this value, equivalent length of the fitting calculated by user is 328.921. 328.922. Press next. Simulator displaying user calculated LE by D and simulator calculated LE by D, and then enter another flow rate 20 LPM. At this flow rate, user calculated LE by D is 328.57. Press next. And like this, all the values can be checked, and then go for Hg manometer with this some 40 flow rate, 40 LPM. At 40 LPM, user calculated Le by D is 332. After this, press the button comparison plots. This is the plot between equivalent length of the fitting calculated by user versus simulator. If both the values are coinciding exactly, points will be on this line. If they deviate, points will be away from this line. These readings are almost coinciding, so points are almost on the diagonal. And then enter average LE by D. Average LE by D is 329.728. 329.729. Incorrect equivalent length. Okay, some decimal change also it displays incorrect. Click on marks obtained. It is giving 33% of marks in this session you got. It calculates if it is almost near, if it is very far, then it takes out the values. Out of 3 values, your one value is correct, this value, so you got 33% of marks. And if you try to enter any flow rate with which you have not done experiment, it shows up some error, not an experimental flow rate with Hg manometer. Okay. And at any point of time, if you want to go to the main experiment, you just click this experiment window. This is the experiment window. Yeah, this is how you will proceed with this simulation tool. Thank you.